The identity element, like we just said, it's the element that you can add or multiply anything to and get the same thing out. So with addition, it's 0. With multiplication, it's 1. An identity element is whatever you can do. You can multiply anything by it, or add anything by it, or divide anything by it, and you'll get the same thing out no matter what. So an inverse element is something that's going to give you the identity element. So with multiplication, that's 1 times 1 equals 1. So for 1, our identity element is 1. So if we have 2, we need to multiply by 1/2 or divide by 2. So, for 4, it's 1/4. So for multiplication, to undo this multiplication that we're doing and get 1 at the end, we're just multiplying by the fraction with 4 on the bottom. What's up? We're trying to get 1 because I'm trying to explain this without going directly into matrices, because it's not something that you're just gonna get with matrices. This is 1 is called the identity element, and it's just kind of the base element of that group. And this group is multiplication. So when we multiply by 1, we're always going to get whatever we multiply by. So that makes it identity. Does that make sense? Mm-hmm. Okay, so if we, with matrices, our identity element looks different. It is a square matrix, and it has 1s along the main diagonal and 0s everywhere else. So any matrix we multiply by this, we're going to get the same matrix out. So our goal today is going to be figuring out how to get something to equal this. So we're going to multiply some matrix with some numbers in it, 2, 4, 6, 8, 1, 2, 3, 4, 5, I don't know, times something to get this. But the way we do that, what those elements are called inverse elements, and they kind of cancel out whatever you do. So if we have this and we want to cancel it out, we're going to multiply by the inverse, because we can't really divide a matrix. Here, we multiply by 1/4. So it's kind of the same thing that we're doing here. We're multiplying by whatever is going to give us the identity element. And there's a way to find this specifically for square matrices mostly. And the first thing that we need to know is, does it have an inverse? Because you think, okay, every multiplication number, every whole number is going to have an inverse because you can just do the fraction. And that makes sense, but matrices aren't quite as simple. They don't necessarily have an inverse. So we have to be sure that they do first. And we do that using the determinant. And the determinant is spelled like this. And we use this formula to check if it is invertible, is what it's called. So if we have a square matrix, this is where we're getting these letters from. So if we have...
Mr. Albright, is that a D?
Yes. Is that better? Okay. So if we take the determinant of something that looks like this, or we need to see, okay, AD, Jakayla, can you mute yourself again, please? Thank you. So we can take AD, so A D minus BC, or 1 times 4 minus 2 times 3. And if this equals 0, we know that there is no inverse. If it equals anything else, we can invert this matrix. So if we work this out, we get 4 minus 6, and that's going to give us -2. So we know that we can invert this matrix. So the way that we do that for a square 2 by 2 matrix is we flip these two, and then we turn these negative. So when we do that, it is going to look like this: 4, 1, -2, -3. So you flip everything on the main diagonal, which is this, and then you turn everything else negative. Negative, and this becomes negative. And we end up with the inverse of this matrix right here. And we know that because we found out if it was invertible by doing this. And then we went directly to flipping these, turning everything else negative. So just to prove that it is the actual inverse, when we multiply them, what we should get is the identity matrix. So let's try it. 1, 2, 3, 4 times 4, -3, -2, 1. So how do we multiply this, people who have done it?
Row by column.
Okay, so tell me what I should write.
1 times 4.
1 times 4 or 1 times 2?
1 times 4.
It's 1 times 4.
That's what I said.
Somebody said 1 times 2.
1, 2, trying to tell you which ones you take to.
Okay.
Oh, I set it up. Yeah.
1 times 4, and then what?
2 times 2.
Do I add them, subtract them, multiply them, put them in a different spot?
After you multiply both of them, you add them up to get your value for the first, whatever you want the first one first. If that makes sense.
Okay. So I draw little arrows because it helps me. And then we finish that, so we move our little arrow across. Now we have 1 times -3, and then 2 times 1. So then we move this guy down.
What's the answer to 1 times? 1 times 4 is 4. And
I'm just writing out all the math first, and then I'll work it in just a second. I tend to make mistakes when I don't write it all out. So now we do 3 times 4 plus 4 times -2. And then three times -3 plus 4 times 1. Okay. So now we simplify this down. Let's see what we get. 3 times 4, or I'm going to start in the top left. 1 times 4, 2 times -2. So that should give us 0, shouldn't it? 1 times 4 plus 2 times -2. So 2 times -2 is going to give us -4.
Oh yeah, it is. So that's 0. That should say 5. You said 4.
So we start here. We go 1 times -3, 2 times 1. So we end up with -1. And then on the bottom left, 12 plus -8, which is going to give us 4. And then 3 times -3, -9 plus 4, which is going to give us 5. So that is definitely not an identity matrix.
Yeah, because which one is it supposed to match? 4, -3, 2, and 1?
This is supposed to match this. It's, well, what this is supposed to look like is this. So maybe we did something wrong. Maybe we just didn't do it quite right. So let's work another example and see. We'll see if we can work number one. Identity matrix. Well, this is the identity matrix. So that was pretty easy.
Wait, what am I looking at?
Number one?
Yeah, number one. 208?
What?
We on 208?
Yes.
That's what I said.
Okay, so number one is just identify the identity matrix. This is the identity matrix.
Oh, that's the basic
I said
identity
even
matrix?
borrow.
That is, an identity matrix is always square. So it'll always have the same number of rows and columns. And it, so it doesn't have to be 2 by 2, but it does have to be square. Make sense?
Let's go.
Okay. So if we talk about, maybe number 3, if the denominator in the formula to find the inverse is equal to 0, then a matrix is considered singular. That formula is this. AD minus BC. So singular means that we cannot invert it. So that would actually be correct. So if your determinant is 0, you can't take the inverse of it, or it is singular. So if we multiply two matrices and obtain the identity matrix. So if we multiply two matrices like these two, maybe if I can scroll to it, and we get 1, 1, 0, 0, are these inverses of one another? Why? What makes it an inverse? But the whole point of, well, an inverse is something that you can multiply and get this out. So if you get this out, they're always inverses. So it's like if you multiply 2 and 1/2, you're going to get 1. So they're inverses of one another. They cancel each other out.
Remember that one YouTube video we watched and the lady said 2 times 2 equals 0?
Okay, so going through the rest of these, all it wants you to do is figure out the determinant, which is this, or just really all you need is this. And if the determinant of this is, if this equals 0, then there is no inverse. If it does not equal 0, there's an inverse. So for these, what you need to do is go through and plug in this formula. And if you get 0, you know the answer to the question. And if you get something else, you also know the answer to the question. Number 2.
It's hard.
Multiplying. Okay, so let's think about it. So let's start with the last one and work up. So the determinant of a square matrix is the sum of all its elements. So the determinant we know is this formula, or well, the bottom part of this formula, AD minus BC. So let's take the determinant of 1, 2, 3, 4 and see if that equals what we're talking about. See if that equals the sum. 1, 2, 3, 4. So we need 1 times 4. minus 3 times 2. 4 minus 6 is going to give us negative 2. So if we add all these elements up, we're probably not going to get anything negative because they're all positive. So we know that D isn't true because the sum of all the elements is going to be 3, 6, 10.
It's B.
Is it?
It is, because you said it was B.
That's with multiplication, not with matrix
Oh,
multiplication.
then it's, I don't know.
So 1 over 2, 3 could represent a matrix.
Yeah.
It definitely can.
How? Because it says it's 1
That's
over A
the-
minus B.
That's the equation.
Yes, but this isn't, it's not a matrix. So we take the matrix and we plug it into that formula. We don't have a matrix in a formula like that. And you can't divide by a matrix. So we definitely can't do that. So we move up and we look at B.
B in like Spanish.
Multiplying by 1 is the same as multiplying by the matrix itself. So that's saying multiplying by 1, like times 1, is the same as 1, 2, 3, 4 times 1, 2, 3, 4.
No.
Reasonable? Not really reasonable, is it? You're going to get something way bigger than that. So that leaves us with multiplying by the identity matrix has no effect on the original matrix, which is correct.
What's the identity? Oh.
Me and you directly had this conversation just a minute ago.
1, 0, 0, 1.
1's along the diagonal and 0's everywhere else.
Why does it have no effect on
That's what I'm
zero?
saying.
So it's like if you take, let's multiply by an identity matrix. So
Right,
It's B line. It'd be line.
Okay, Mr. 26.
There's no replacement.
all right, let's multiply. So we start like this. 1 times 1 plus 0 times 3. 0 times 1 plus 1 times 2. So then we stay here and we move here. Okay, so 3 times 1 plus 4 times 0.
0,
And then 3 times 0 plus 4 times 1. All right, so if we work this down, we're going to get 1 on the top left. We're going to get, looks like 2 over here, 3,
Oh, no wonder.
and
why.
4. So that's what it means that it doesn't have any effect. It's just like multiplying by 1. This is 1 for matrices.
Oh.
So when you multiply by the identity, you're just going to get whatever you put out in.
I guess that's not really long.
That's weird.
Yeah, it is. And you can also know that non-square matrices do not have inverses.
Is this true or false? I
Mm,
mean, yeah, we did that. It's false, right?
It's true.
no, it's true.
Um,
I believe. Let me look back on the definition of
You
singular.
said the determinant something is 0, you can't take the inverse for it.
What?
That is correct.
Says,
Okay,
Hey,
so do we feel okay on inverse matrices?
it says true or false, and this man says yes.
no, I said true. It says a T.
All right, let's move to linear systems.
It says a T. Where at it?
Number 4. Yes.
It says
Oh.
a T.
True or false? Yes.
For 8, 9, and 10, those are easy.
Mm-hmm.
Bro.
They shouldn't take you very long at all.
It's
Well,
for
no, because you all you
true,
gotta put is yes or no,
Mhm.
and if it's a square matrix, you put yes.
it's for true too, I put true,
Yes, that's true.
it is true, because I just looked at
Patrick
it.
said, Patrick said yes.
Okay, so linear systems. There are a couple of ways we can handle linear systems. And I think the most complicated way is by using a matrix. And of course, that is the way that they want you to do it. So we're going to look at how to do that. And hopefully it won't be too bad. Hopefully there aren't too many questions that require you to do it this way. So we talked about before how to do systems of two equations or systems with two variables. So if we have 5x plus 5y equals 13 and something else with x and y in it, then we know how to do that. We just solve for one of the variables and plug it into the other one. With three variables, we can still do that process, but the way that they want you to do it is by setting up matrices. And the way that you do this is you set up your coefficient matrix, which is all your coefficients of all your numbers all together. 5, 5, -4. I'm doing this for number 1. Solve the system. 5, 3, 1, 3, -2, 1. So it's that times your variable matrix equals your answer matrix. So I'm just gonna answer 1, answer 2, answer 3. So the way that we do this is how we would do this with a regular equation. If we said, okay, this is x and this is some number like a, I don't know, a times x equals whatever we're looking for. So answer.
Which one are we on?
Number 1
All three of them?
on 209.
Oh, I see that.
Are you?
No.
Okay, so what we would do in this situation is we would divide by little a to get x by itself, and that would give us our answer. But we can't divide by a matrix. So what we have to do is do the inverse instead. It's like instead of saying we're going to divide by 2, we're going to multiply by 1/2. Same answer, same process, just multiplication instead of division. So here what we have to do is multiply by the inverse of a, usually written like this. And if we do it to one side, we have to do it to the other side. And what that's going to do is cancel this out. And we're going to get x equals our answer. So if we do that, the first thing we need to do is figure out if this is invertible. And then we need to figure out how to do the inverse of it. So let's figure out if it is invertible. Let me do some Googling real quick. Okay, so I believe what it is going to want you, it actually wants you to solve these with like Desmos or Symbolab or something like that. So I'm gonna do that. I'm gonna pull it up and do it that way. So because things that it did not teach you how to do, it expects you to know how to do in this section, or it expects you to use a calculator or something like that. So if we go to Symbolab, there is a matrix button right here. And you can choose your size, or you can click this and make your matrix whatever size you want, up to 10 by 10. If you're working with 10 by 10 matrices, you're doing some serious work. So we are looking for, I believe, a 3 by 3 for this. So 3 by 3. That is not a 3 by 3.
Don't we need to make, the last one, the matrix a negative one?
It should have been. I apologize. Good catch. Okay, so 5, 5, negative 4, 5, 3, 1. 5, 5, negative 4, 5, 3, 1. I know that this is a negative 1. So 3, negative 2. Okay, so maybe we want the inverse of this. So I'm going to raise it to the negative 1 power. And that is raised to the negative 1 power. It's not multiplied. It just looks funny. So let's see what that gives us. Okay, so we have an inverse matrix right here. So we know that this will calculate the inverses, and we know that we know what we need to do. We need to set up this in the equation, and we also need to change these out for the actual answers. They're on the other side of the equal sign. So we have 13 here, negative 3 here, negative 10 here. So all I'm going to do is type this exact equation, or this exact long problem, into Symbolab, and I'm going to see what it gives me. Could give me the right answer, it could not, and if it doesn't, I'm going to show you how to mess with it and make it give you the right answer. 13, negative 3, 10. So X, Y, and Z equals, what does it say now? 13, negative 3, and negative 10. On number 1, those are on the other side of the equal sign.
That's smart. We used to all go.
All right,
Almost like this.
almost. All right, so let's see what it gives us. Ooh, those look like 3 answers right there.
Is that wrong?
No, it's the right answer.
Yep. So X is negative 2, Y is 3, and Z is negative 2 as well. So when you go to find these, the problem is going to be setting up the problem, not actually solving it, because you don't know how to do the inverse of this and all of that. So if you set it up, you plug it into Symbolab, and it's going to give you the answer.
Did you do that for like
You do
all
that
equations, if they're not? Word problems?
Do it for,
Negative 2 is Z. He
Could
said
you like
negative
plug any
2 is
equation
wrong.
in the symbol lab, even like?
pretty
with a
much.
drop of word problem?
Yeah,
Pretty much.
negative
It's very
is-
helpful.
Does it do word problems or
That is
not?
positive 3.
How's that positive?
2, 3, negative 2. So we know that X
X is a negative.
is 2, Y
Why
is
not
3.
negative?
Why would it be?
Because it got a minus sign.
It's 2 negative 2s and 1 positive 3.
Yeah, it's negative 2.
Where?
It says X equals negative 2, and then it looks like it says Z equals negative 2.
Mm-hmm.
And then it looks like it says, I can't see because it says unmute your microphone.
Y is 3.
Y equals 3. So negative 2, 3, negative 2.
Sounds like I'm a tutor.
No.
Okay, so these are our solutions for X, Y, and Z. So if we go through and set the second problem up, I'm not going to plug it into Symbolab this time, but what we're looking for is a coefficient matrix Sure. We need a variable matrix.
Guess what? 1, -4, -1, 6, 3, -1, and 1,
And then answer matrix.
21.
That's the format you're after. We're not going to do number 2, or I'm not going to do it. But this is the format you're going to use when you set it up. And then you're just going to plug it directly into the calculator. And it wants you to use Desmos, but I mean, I think Symbolab works a little easier.
This one is hard.
So, okay, so let's look at number 5.
What? That's probably.
It's a word problem. So you have 37 coins that are nickels, dimes, and pennies. The total value of the coins is 155. There are twice as many pennies as dimes. Find the number of each type of coin in the bank. Okay, so we're going to at least need to set up 3 equations. So let's try to work through this and see what our 3 equations are. So we say, okay, we have 37 coins that are nickels, dimes, and pennies. Okay, so we have 37 of these guys. So I'm just writing this down as possibly my first equation. And we know that we're going to have X, Y, Z, or I'm going to do pennies plus nickels plus dimes, just to make it clear. Okay, so the total value of the coins is 155. So if we set this up as our second one, then we say, okay, pennies times 1 plus nickels times 5 plus dimes times 10, just because that's how much they're worth. And we're talking about worth now. So maybe that is our second equation. There are twice as many pennies as dimes. So if we go for a third equation and we say,
Why don't we just look it up on Coursera?
so maybe pennies times 2 plus dimes. Nope. Pennies plus 2 equals dimes. I do not. You have 37 coins that are nickels, dimes, and pennies. Okay, so maybe this goes in our second or our first equation up here. So if we say, okay, we have two pennies. Maybe not. I'm trying to think through it as well. Okay, let's roll with this and see what we get. Maybe we get something reasonable. Maybe we don't. Maybe we did it wrong. So what I'm going to do first is I'm just going to say, okay, plus 0 nickels, because we know that we don't have any nickels in this equation, but we want the variable anyway. So now what I'm going to do is subtract dimes across to the other side. And I'm going to be left with 0 on this side, just so that way I have all my variables on one side and in the same order. So let's plug this in like this. Let's actually rearrange these guys to be on the other side. So now we want to set up a matrix. So we're looking for a coefficient matrix. 1, 1, 1, 1, 5, 10, 2, 0, -1. So now we want our variable matrix, or
Answer.
what you got?
Okay, so the first equation is 0.01p plus 0.10b equals 1.55.
Okay, that would be this one. I did it slightly differently, but okay.
P plus n plus d is 7.
Okay.
P equal to d. And then it says we need to convert the last equation to standard form. So P equal to D would be P minus 2D equals 0. P plus 0n minus 2D equals 0. Remember the coefficient for nickels when writing the matrix.
Okay. Does it say in the problem that there are twice as many dimes as pennies or pennies as dimes?
It says that for P equal to D, it says twice as many pennies as dimes.
Okay.
And then it says the matrix should look like this. The first matrix is a column matrix. Is that the one that just goes straight across?
Column has a column.
Also, row matrix just goes straight across?
Yes.
Your matrix should look like 0.01, 0.05, 0.10, and 1.55. That's the first one. And then it says the second matrix is 1, 1, 1, 37.
Okay.
Then it says the other one is 1, 0, -2, 0. And it says now reduce the matrix to reduce row echelon form. So then it's the first matrix is 1, 0, 0, 20.
We got it set up. We're good.
And then it says 20 pennies, 7 nickels, 10 dimes are the 37 coins that the total is $1.55.
So most of that, what they just did with what you told me, is by hand, and they don't want you to do it by hand. The part we needed out of that was this, and it changed a couple of the things, and it really shouldn't have made all that much of a difference, but regardless, we got it. So let's plug this in to Symbolab.
Yeah.
That looks good.
Now, if it wasn't for the internet or Mr. Albert, I would have been doing this. Okay, 2-6.
Okay, so we have a 3x3 matrix. We do 1, 1, 1. And really the important part is the equations. It's not which order that they're in, just as long as you keep it straight. 0.05 and 0.1. And now we need -2, 0, and 1. So we will change this to be pennies, nickels, and dimes. And then we need 37, 1.55, and 0. Images.
Yeah.
So this is what it gives us. All right, guys, so I think we are going to run out of time. We're definitely going to run out of time before we can do another problem or another, yes, it should be. Or before we can do another section. So I'm going to call it quits today. Y'all have a good day.